Hi and welcome to the lesson on the absolute value function. Some people call this the modulus function. It's the same thing, absolute or modulus. Now this is, as I explained in class, this is kind of like a Photoshop layer that you can put over the top of other graphs. So it doesn't actually affect the graph essentially, but it changes the way that it looks because it's a layer that we put in over the top. So it can be applied to any graph at all that we'll see this year. And sometimes they can look a little bit ugly, but the actual idea of them is not too challenging. So stick around and hopefully you'll learn a little bit. Now I've just got this standard form that I just like to use every single time because I want to tell you that the same rules apply for transformations and all of those sorts of things. The only thing the absolute does is it makes all of the negative values positive. The actual idea of absolute is that it does the square root of something squared, like this. So you can imagine if x is a negative number, it becomes a positive number, squared, but then it's the square root. So let's just do an example of if x equals -1 and compare that with x equals 1. Okay, when x is -1, it's -1 squared, which is +1, and then the square root of +1 is just 1 anyway, so y equals 1. And same over here, as you'll see, y also equals 1 as well. So what ends up happening is that this square root of x squared can be, you can get rid of that kind of language or those symbols and actually replace it with these lines here. These are the absolute signs. They can be found on your calculator as well, which I'll just go and find. Where are we? Oh, I've just got to cancel that. Hang on. Yes, I want to quit. If you look at, here we go, where are we? If you look at this little button over here, that one will give you the absolute signs, which is this one here. Okay, you can graph that using that. You can just find out numbers using that. You can do whatever you like. Okay, so back to our page. So what I've got here is I've got y equals absolute value of x. Now what I would like you to do is just to draw the things inside the absolute signs first. Okay, and then apply the absolute sign to it, or the modulus sign. So what I'm going to do is I'm going to draw y equals x first. Okay, that's this line along here. Okay, that's y equals x. Now what this absolute sign or modulus sign does is that it makes all the negative values down here, all the values below the x-axis, it makes them positive. Okay, just like we were doing over here. Instead of being, it should be if x is -1 for y equals x, it should be down here. But because of the modulus sign, it makes it +1, and instead of -2, it makes it +2, and so on and so forth. Okay, so we actually end up getting this kind of sharp point down here on the x-axis, because that's where it bounces. That's where it changes. So these two lines actually have two different equations if you wanted to. So this equation could be y equals x, and this equation here could be y equals -x. Okay, and that will be helpful really, like a lot later on. So let me just jump into, I should also mention the domain and the range, but you can probably sort of already gather that from there. Let me jump into a question that is a little bit trickier, but the same ideas apply. So for example, this question here. The first thing that I want to do is I want to rearrange it so that I'm used to, so it's in the form that I'm used to. So I'm going to put the +3 on the end. I'm going to make the x and the 2 swap. So it's negative modulus x plus 2 plus 3. Okay. Now I encourage you first of all to draw inside the modulus first. Okay, I'm going to do that up here, like little rough notes. So I'm going to draw x plus 2 first up here, which is this line just there. Okay. Now I'm going to apply the modulus sign to it. Okay. The modulus sign would mean that this bit down here is gone. So I'll get rid of that, and all I've got is that up there. It's a mirror image up the top. Okay, and now I'm simply going to add all of the other transformations onto this. So I'm going to reflect it, I'm going to translate it both left, and I'm also going to translate it up 3 as well. Okay, just like I would with any other graph. So this negative means it's a reflection in the x-axis, as I've written down there. So instead of looking like this, it now looks like this. I'll do it in a different color, and I might even get rid of some stuff too if I can. Yes, there we go. So it actually looks like that. Okay. Now I know some people will say, oh, but hang on, that's now below the x-axis. I thought that the modulus sign makes it above. And that's true before, but then if you can always reflect, translate, or do anything else to the graph to then move it down into the negative as well. The modulus only applies to this x plus 2. It doesn't apply to the whole graph. Sometimes you will get things apply to the whole graph, but this one only applies to that. And then I'm going to move it, translate it 2 units to the left. So this point is now 2 units across, down here, and 3 units up. So I end up getting this graph down here. And I could find out the x-intercept. The y-intercept is really easy to find out. Just put x as 0 into here, and then I've got 0 plus 2. Now, when you do the modulus of a number, it doesn't change the number at all. It just makes the number positive. So if it was negative, it makes it positive. If it was already positive, then you can just get rid of the absolute signs. Okay, so this will end up being negative 2 plus 3, which is positive 1, which is there. So that can be 0, 1. I can find out these x-intercepts, and I might do that a little bit later after we've seen a couple of other modulus things. So that's the first example, and there'll be a couple of parts to this video. So yeah, if you're happy with that, you can move on to some of the exercises in the textbook, but if you want to watch the next couple just to get a better idea, then please do.